Good day, everyone. Today we are going to be looking at temperature and its measurement. Temperature and its measurement. So, something very important you're going to do for me now is to ensure you have subscribed to this channel. Please click on that subscription button to subscribe. It just means you are following us on YouTube. It's free to do it. You won't go use any money. It's not going to cost you anything. So, as you are subscribing, as you have so much subscribers, we'll have more strength to do some other important videos. So what you have to do is just click on that subscription button. That is, if you're not registered with YouTube, just use your valid email to do this registration and follow us by subscribing. It's free to do it. You're not going to use any money for it. So, and as well, turn on that notification bell, and please, very important, don't skip any part of this video so that all things or all the information you're going to dash out in this class, you'll be able to receive all. So if you miss any part, you click any part, it might mean the vital part of this video. So don't click or fast forward anything, or ensure you watch it to the end. So don't skip any part of the video. You don't want to miss the most important information in this section. So please, we are going to look at temperature and how it is measured. So temperature is defined as a physical property or quantity that characterizes the thermal state of a body. I can put it this way. It is a physical quantity. It's a physical quantity that gives or that denotes the thermal state of a body. Denotes the thermal state of a body. What does it mean by that? It means that temperature is the degree of hotness and coldness of a body. It shows up how hot or how cold a body is. That's what we call temperature. So we call temperature. It gives us how hot or how cold a body is. So it's the degree of hotness and coldness of a body. And this temperature we are talking about, it can be measured with an instrument called a thermometer. That's what we use to measure temperature. We use thermometer to do the measure. We have to measure what we call temperature. Now, before you calibrate a thermometer or a temperature scale, there's what we call temperature scale or scale of temperature. What is a temperature scale? What is a temperature scale? A temperature scale is a definite number on an arbitrary scale in which the degree of hotness and coldness of a body can be expressed. If you want to something like give or adopt a temperature scale, there are some procedures you follow. You must choose a body that have a defined thermometric property, and you must mark what we call the upper and lower fixed point of the scale. You must mark the upper. There's something called upper and lower fixed point of the temperature scale. We are going to go into that later. And there's also what we call something very important. That's called the thermometric property of a substance. The thermometric property of a substance. Now, this is a physical property of a substance that can vary or that can change in a known way with temperature. So that physical property of a substance that can change or varies in a known way with temperature, and it can also be measured by the means of gauging temperature. But note that it is that property of a substance that can change or varies in a known way with temperature. For example, a gas, an ideal gas whose volume is kept constant. If the pressure of that gas increases, the temperature will also increase. So that will lead us to something like constant volume gas thermometer. Because if you have an ideal gas and the volume is kept constant, you can use the ideal gas to make temperature. As the pressure is increasing, the temperature will also increase. So that varies in a known way with temperature. We also have the resistance of a platinum wire. Now, if temperature of a wire increases, the resistance will also increase as far as the wire is a good conductor. So we can also use that as the thermometric property for something like liquid. We also call liquid in glass thermometer. It also has some thermometric property, which is the length of that liquid column in a glass capillary tube. In a what? In a glass capillary tube. So some properties of thermometer or some thermometric property of substance that we have are the length of liquid column in a glass capillary tube, the resistance of a platinum wire, the pressure of an ideal gas whose volume is kept constant. We also have the electromotive force of a thermocouple, and so on. All these things varies in a known way with temperature, so they can be used as a thermometric property. Then we also call it some useful temperature scales that we have. Some useful temperature scales that we have. Example of that scale is what we call the Kelvin scale. Now, Kelvin scale is also known as the thermodynamic scale. When I say Kelvin scale is also known as the thermodynamic scale. It is based on the theoretical efficiency of a perfectly reversible heat engine. This is based on what? The theoretical efficiency of a perfectly reversible heat engine, and the upper fixed point of this Kelvin scale. The upper fixed point of this Kelvin scale, the upper fixed point of the Kelvin scale, the upper fixed point, the upper side is 373 Kelvin. That's the upper fixed point. That is the upper fixed point. Highest you can see on the scale. Then the lower fixed point on this scale. The lower fixed point you can see on this scale. The lower fixed point you can see on this scale is the lower fixed point of this scale is 273 Kelvin. That is the lower fixed point of your Kelvin scale. Although these are just approximate values. If you want to give it in the true way, the first one will be 373.16 Kelvin. But if you approximate this, you are going to have this. The second one will be 273.16 Kelvin. If you approximate this, you are going to have this. So this is the approximate value for the upper and lower fixed point of the Kelvin scale. And we also have what we call the ideal gas scale. The ideal gas scale. Whose something like the working substance inside is the fixed mass of an ideal gas. The fixed mass of an ideal gas, and the lower fixed point of that scale, that ideal gas scale, the lower fixed point, not the upper now. The lower fixed point of that ideal gas scale is the absolute zero temperature. The lower fixed point of that scale is the absolute zero temperature. And what's the absolute zero temperature? 0 Kelvin. That's absolute zero temperature. Or minus 27, or we're going to get there later, minus 273 degrees Celsius. So 0 Kelvin is the absolute zero temperature, and the upper fixed point of this scale is the temperature of the triple point of water. The temperature of the triple point of water. And what is that temperature of the triple point of every water? The temperature of the triple point of every water is the lower fixed point of Kelvin scale, which is 273.16 Kelvin. 273.16 Kelvin. That is the temperature of the triple point of water. That is the upper fixed point of an ideal gas scale, while the lower fixed point of an ideal gas scale is 0 Kelvin. Now, something still very important. Now, for an ideal gas scale, the pressure changes with respect to temperature. For example, let's say we have an ideal gas varying temperature, and you want to calculate the temperature on the unknown temperature on an ideal gas scale. There's a relation we use for it from interpolation, that the unknown temperature on an ideal gas scale, the unknown temperature on an ideal gas scale is equals to the pressure at the unknown temperature divided by the pressure at triple point of water times 273.16 Kelvin times 273.16 Kelvin, where this T is the unknown temperature on the ideal gas scale. This PT is the pressure that corresponds to this unknown temperature. Then PTR, so I have subscript R. That PTR is the pressure at the triple point of water. The pressure at the triple point of water. I can ask you a question. I'll ask you a question like this. I'll say, oh, if the pressure at the triple point of water is 98 Pascal. If the pressure at the triple point of water is 98 Pascal. Example 1. Let's look at this example regarding to this gas case, or the variation between temperature and pressure on the constant volume gas, or constant volume gas thermometer. So let's look at the question. Let's say if the pressure at the triple point of water on a giga scale is 98 Pascal. That is temperature at 273. Remember the temperature for triple point of water is 273. So if the pressure, not temperature, if the pressure at that 273 is 98 Pascal, and the pressure at a particular temperature T, and the pressure at a particular temperature T is 50 Pascal, and the pressure at a particular temperature T, and the pressure at a particular temperature T is 50 Pascal. So this is the pressure at the triple point of water, this is 98 Pascal. The pressure at a particular temperature T is 50 Pascal. What will be the value of T? What will be the value of T? So T will be equal to what? So we already said T is equal to PT all over PTR times 273.16. So this is the unknown temperature at this pressure. Now this is the pressure at the triple point of water. Anyone can come up as the question. So let's look at this and see what we're going to have. So the value of T will be the pressure at the unknown temperature is 50. The pressure at the triple point of water is 98 times 273.16. So if you solve this with your calculation calculator, without time, that your calculator calculator, you solve with that calculator calculator, what you are going to have we'll be having something like we have 50 divided by 98 times 273.16. So if you solve this, you're going to have 139.4 Kelvin. That is the temperature you're going to have. 139.4 Kelvin. So if you do this, 50 divided by this times this, you're going to have, this is the pressure, this is the temperature at 50 Pascal. So how we are following. Now, this is just something like a preamble or introduction to the course. So we are still going to have something like, we still have called useful or types of thermometers. And there is another scale we do use, although we don't call it a scale actually, although they still call it a scale, which is called Celsius scale. Yeah, it's still called a scale. It's Celsius scale. Now, Celsius scale is another useful scale we use if you want to measure the temperature of the body, or if you want to calibrate a thermometer, we use Celsius, so degree Celsius to calibrate it. Now, for degree Celsius or for Celsius thermometer, we still have upper fixed point, which is the higher side of the scale, and we still have lower fixed point, which is the lowest side of the scale. So the higher side of that scale, is the upper fixed point for Celsius, is 100 degrees Celsius. Then the lowest point of that scale is 0 degrees Celsius. So the upper fixed point is 100 degrees Celsius, while the lower fixed point is 0 degrees Celsius for Celsius scale. It's also known, you can also call it customary scale. And it's still very, very useful. We still have what we call fundamental interval in the temperature, or in the thermometer, or in the temperature scale. Now, the fundamental interval of this scale now is the upper fixed point minus the lower fixed point. Let me of the fundamental interval, which is 100 and 0, that is 100. So the fundamental interval in this case now is 100. For the first one we did was 373 and 273. You see subtract, you're going to have 100. You see a Fahrenheit scale, you see a Rankine scale, and so on. And so on. So before we go into interconversion of temperature scales, there is something very important we are going to do. We're going to look at types of thermometers. Now, the first type of thermometer we have, or I have here, or I want to call out now, is the constant volume gas thermometer. And we also have the platinum resistance thermometer. We also look at that. We also have platinum resistance thermometer. Then we also have the thermocouple thermometer, radiation pyrometer. We also have liquid in glass thermometer. Which can either be the mercury in glass thermometer or alcohol in glass thermometer. So this thermometer I just called has their advantages and they have their disadvantages, in which you can look at in your closest. Because of time, we're not looking at that per se, because we want to look at how to interconvert from one temperature scale to another. That is the second thing we're going to look at in this space today. So let's look at interconversion of temperature scale. Now, a thermometer can be calibrated in millimeters, a thermometer can be calibrated in cm, a thermometer can be calibrated in ohms, and so on. This thermometer was calibrated in Pascal, and we're using pressure to do it. But we know that the pressure at the point of water, we already know it to gauge the. I also read the pressure at the temperature we are looking at. So from this relation or from interpolation, we're able to get the answer. So we're going to look at interpolation, how to interpolate to convert from one temperature scale to another. So interpolation, or the interconversion of temperature scale. Interconversions of temperature scale. That is how to convert from one temperature scale to another. So I've called Celsius and Kelvin scale. I call Fahrenheit, Rankine, and so on. So before you do interconversion, when you can convert from one temperature scale to another, there's something you're going to do. You must know the upper and the lower side. The lowest side and the highest side of that scale, or the upper fixed point and the lower fixed point of that scale. So for the first two we just got, which is the Celsius, and for Kelvin, okay, we know that the scale for Celsius has 100 at the upper point, then the lowest side is 0. Then the scale for Kelvin, we know that it has 373 at the upper side, then 273 at the lowest side of this scale. So what I'm going to do, let's assume this thermometer is reading in degrees Celsius. This thermometer also reading the equivalent in Kelvin. So what would be the equivalent degree Celsius in this case to Kelvin? For example, now if this one is reading 90 Kelvin, what would be the equivalent in degree Celsius? That's what we are trying to look at now. Now, the first thing I'm going to do, we're going to apply the principle of interpolation. How do you do it? You resolve a mathematics operation in this place, and ensure you repeat the same mathematics operation in this other side. Although it is very good to look at an operation in which you can easily result. Now, for example, how we normally do it? I will pick the unknown. What is the unknown in this place? Degrees Celsius. Now, this is called interpolation. You can pick 100, you are free. But ensure the mathematical operation you are running in this place is also what you are going to run in this place. But how I do my own, I'm going to pick the unknown minus the lower fixed point. Okay, the unknown, I'll remove the lower fixed point, which is 0. Then I'll pick the upper fixed point, which is 100, minus the lower fixed point, which is 0. Then I will equate it to the same thing here. Now I picked the unknown here. What is equivalent to this unknown in this place? Which is k. I will pick the same k. Then I pick 0 minus what is equivalent to 0 here? 273. I'll pick this 273. Then over, I picked 100. Now what's equivalent to 100 here? 373, the minus, and I now pick 0 again. What is equivalent to 0? 273. So the next thing, C minus 0 half degree C over 100 is equals to K minus 273 over 100. So this 100 we cancel out that other 100. Then we are going to be having degree C is equals to K minus 273. This is nice, this is nice, this is nice, this is nice. So please, this one is a Kelvin actually, this one is a Kelvin. So please take note of that. Or let's just call it 273 anyway. And this means if you want to convert a number or is a value of the temperature from Kelvin scale to Celsius scale, we are going to subtract 273 from that value. E.g., for example, I can ask you to convert or 273 Kelvin. I ask you to convert 273 Kelvin to Celsius, degree Celsius, to degree Celsius. I ask you to convert that. So if I ask you to convert 273 to degree Celsius, what I'm going to do for me will be, we said degree Celsius is equivalent to Kelvin minus 273. So we are going to remove what is the Kelvin scale, what is the Kelvin temperature we have here? 273 minus this 273 that's already in the equation, and I'll give you 0 degree Celsius. So 0 degrees Celsius is the same thing as 273 Kelvin. You can see it here, qualified. 0 degrees Celsius equivalent to 273 Kelvin. You can also have others. Now let's look at for Kelvin now. If you wish to make this Kelvin inside the formula, K will now be equal to, if we move this one to this other side, let's say we are moving this 273 minus 73 to the other side, it will now change to degree C. Then this minus, if we crosses this equal to sign, we change to plus 273. So that means if we are converting from Celsius to Kelvin, we are going to add 273. We are going to add what? 273. Now, e.g., convert, let's say 0 degrees Celsius to Kelvin. Convert 0 degrees Celsius to Kelvin. So what I'm going to have to just be, Kelvin will be, what is in degrees Celsius here? 0 plus 273. That gives us 273 Kelvin. Is it true? Yes, let's check. 0 degrees Celsius is equivalent to 273 Kelvin. I can also ask you to convert, let's say 27 degrees Celsius to Kelvin. 27 degrees Celsius to Kelvin. How will you do that? I want to move from Celsius to Kelvin. Kelvin is equals to degrees Celsius plus 273. Now just come. What's the degree Celsius here? 27 plus 273. So we're going to do 7 plus 3, that gives us 10, that's 0. 2 plus 7, that's 9 plus 1, that's 0. Then plus this 2, 1 plus 2, that's 3. So that gives us 300 Kelvin. That's what we're going to have, 300 Kelvin. So if you are solving or if you are converting 27 degrees Celsius to Kelvin, you're going to have equivalent value as 300 Kelvin. So that's how you do that. That's how you do that. It's very, 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 very important. It's very, very important. It's very, very important. So let's also look at Kelvin and Fahrenheit. Kelvin and Fahrenheit. Or let's look at Celsius and Fahrenheit. Or because of time, I'm going to do one of them, whether Celsius and Fahrenheit or Kelvin and Fahrenheit. Then you will do the other one at your own convenient time. So I'm going to look at Fahrenheit and Kelvin. Fahrenheit and Kelvin and Fahrenheit. So let's draw the scale for Fahrenheit and draw the scale for Kelvin. So for this Kelvin, we have 373 Kelvin. We have 273 as the lower fixed point. Look at fixed point for Fahrenheit scale is 212 degree Fahrenheit. Lower fixed point is 32 degree Fahrenheit. So this one is reading degree Fahrenheit. What will be the equivalent reading in Kelvin? What will be the equivalent reading in Kelvin? What will be the equivalent reading in Kelvin? So let's go. From that same interpolation rule, you pick this one rule, degree Fahrenheit, minus 32 is the lower fixed point divided by the upper fixed point 212 minus the lower fixed point is 32. This one will be equal to, is equivalent to the same thing here. Pick the Kelvin minus 273 divided by 373 minus 273. So we are going to be having degree set, then Fahrenheit will be equal to minus 32 over this minus this is going to give us 180. So the fundamental interval of Fahrenheit scale is 180. Please take note of that. So let's look at this. This minus this will be K minus 273 over this minus this, that's 100. So the fundamental interval of Kelvin scale is 100. So please take note of that. So let's go. Let's check what can divide. We can divide this now. Let's check what can divide 2. Okay, let's divide this one by 20. 20 divided by divide 100, we will have 5. Now let's check if 20 can divide 180. 20 divides 180, that's going to give us 9. That's going to give us 9. So that will be K, F, and this Fahrenheit minus 32 over 9 is equals to K minus 273 over 5. So the next thing, let's make F the subject of the formula, or make K the subject of the formula. So we're going to be having F will be equal to, cross multiply this to this side, we're going to have 9 and over 5, K minus 273. Then plus, if you move this minus 32 and it crosses this side, you're going to change to plus 32. So this is what we are going to have as your final answer. Look at what I did here. You used to multiply this, you will have this, then you move this minus 32 to this other side, then you have plus 32. Now if you wish to make K, so the solid formula, you're going to cross 5 to this other side, you're going to be having 5 over 9, then degree F minus 32, then is equals to K minus 273. So if you move this minus 73 to the other side, K will be equal to 5 over 9, degree F minus 232, then plus 273. So that's what we have. This is how you convert from Fahrenheit to Kelvin, and this is how you convert from Kelvin to Fahrenheit. The place you take note of that is still very, very important. So we can say, okay, a question now. I can say a question for you to convert, let's say 20 degree Fahrenheit to Kelvin. Convert 20 degree Fahrenheit to Kelvin. So how do you convert from Fahrenheit to Kelvin? You know how to convert from Fahrenheit to Kelvin. So the Kelvin equivalent will be 5 over 9 times 20 minus 32, then plus 273. So if you solve this with your calculator, you are going to be having, let us solve everything through. That was very fast, short time. So if you solve that with your calculator, you are going to be having 5 over 9, that's 5 over 9 times 20 minus 32 plus 273. So what I'm having here, I'm having something like 266 Kelvin. That's what I'm having. 266 Kelvin. You can also check then with your calculator, if your own tallies with this answer. I'm having 266, although there are decimal points which are just approximate. So this is the approximate whole number, the nearest whole number to the answer I'm seeing here. So this is how you convert between Fahrenheit and Celsius and Kelvin and Fahrenheit. So we are going to do now how to do Celsius and Fahrenheit. Celsius and Fahrenheit. So if you want to look at Celsius and Fahrenheit, the same way draw for Fahrenheit, we have for Celsius, we already draw the scale. First thing, taking the interpolation, we have degree Fahrenheit minus 32 all over 212 minus 32. That will be equal to degree Celsius minus 0 all over 100 minus 0. This minus this all over this minus this equal to this minus this over this minus this. So the next thing, we have degree Fahrenheit minus 32 is equals to 180. 180 is equal to degree C over 100. So 22 that is 9, 22 this place, we have 5. So the next thing, we have degree F is equals to minus 32 over 9 is equals to degree Fahrenheit over 5. Now making degree F, so the formula, degree F will be equal to 9 times this, so we will have 9 over 5, degree C. Then if you move minus 32 across this, you have plus 32. That's what we're going to have. So this is how you convert from Celsius to Fahrenheit. When you convert from Celsius to Fahrenheit, we're going to have this. The next, we also have, we can also make degree Celsius is the formula. So we're just going to cross multiply this to this side. So degree Celsius will be equal to 5 times this, we're going to have 5 times F minus 32, as degree Fahrenheit minus 32, then over 9. So 5 over 9, F minus 32. So this is how you convert from Celsius and from Fahrenheit to Celsius. So I can also ask you to convert. I can ask you to convert 50 degree Fahrenheit to degree Celsius. I can ask you to convert 50 degree Fahrenheit to degree Celsius. So what I'm going to do for me, will be decide if I want to convert from Fahrenheit to Celsius. Apply this formula. So I will have degree Celsius is equals to 5 over 9 times degree Fahrenheit is 50 minus 32. 50 minus 32. So we're very fast, you have to be very fast. You apply, just resolve this using your calculation calculator. So if you solve that, you're going to have 5 over 9. We have 5 over 9. 5 over 9. Times 50 minus 32. So I'm having 10. Already. Yeah, that's 5 over 9 times 50 minus 32. 50 minus 32, that's going to give us 18. That's going to give us 18. So 9 here 2, 9 here 1. 2 times 5, that is 10 degrees Celsius. So that's what we're going to have. We're going to have 10 degrees Celsius. The question doesn't come like this. At what temperature would Fahrenheit and Kelvin be equivalent? The reading in Fahrenheit and Kelvin be equivalent. So at what, I can also ask you a question like this. I can also ask you, at what temperature will reading in Fahrenheit be 2 times that in Celsius? So I'm going to answer 2 questions now. The first one is, at what temperature will the reading in Fahrenheit be the same as that in Celsius? Then I also answer another question. At what temperature will the reading in Celsius or in the reading in Fahrenheit be doubled of that in the Celsius? Be 2 times of that in the Celsius. That is the 2 things I'm going to ask now. So the first one is, at what temperature will Fahrenheit reading be equivalent to Celsius reading? At what temperature will both of them be equivalent? So we can say, okay, let the temperature be equal to X. Let's say the temperature of X. Let's say at a particular temperature of S, the reading of Fahrenheit and Kelvin will be the same. If this one is X, it will be S. If this one is S, it will be X. From there, you can calculate the value of S to get your final answer. Or you can just go from here. Now let me first try this formula. If this one is reading X, if Fahrenheit is reading X, 9 over 5, this degree Celsius will also be reading X plus 32. You can also try this. If this Fahrenheit is reading X, this degree Celsius will also be reading X. That will also work out. So let's try this first and see what we're going to have. Let's try it first and see what we're going to have. So this is going to give us X. If you move to this other side, minus 9 over 5 X is equals to 32. So 1 minus 9 over 5, 1 is over 1. So we're going to have 5. So 5x minus 5 to 5, okay, that is 9x is equal to 32. So that is minus 4x over 5 is equal to 32. So that will give us x will be equal to 32 times 5 over minus 1. 32 times 5 over minus 4. So let's check 2 into this place, 2, 2 into 32, 2 into 32, I think that is 16. Okay, 2 can also put 2 here, 1, 2 here, 8. So 5 times 8, that gives us minus 40, either in degrees Celsius or in degree Fahrenheit. So this is the temperature at which degrees Celsius and Fahrenheit we're reading the same thing. You can also apply this formula, this second formula. So let's apply it and see what we're going to have. Let's apply it and see what we're going to have. So if you are placing x in this place, you're also going to place x in this other one, this other side. Both Fahrenheit and Celsius, they're not x and x. So if you open the bracket, you're going to be having x minus 5 over 9x is equals to 5 times minus 32 over 9. X minus 5 over 9x is equals to 5 minus 32 over 9. If you do this, you're going to have 9 minus 5, that is 4x over 9 is equals to this times this. What are you going to have? What are you going to have? Okay, let us say 5 times minus 32 over 9. The next 9 becomes 9. Then you divide both sides by 4. Divide side by 4. Also divide the other side by 4. 4 cancel 4. X will be equal to 4 here. That's 2 here. 2 here. 16. Then 2 again. 1, 2, 2 is 8. So 5 times minus 8 that gives us minus 40 degrees Fahrenheit or degrees Celsius. You can also do it like that. Then it also come from here. It can also come from this place. It can also come from this interpolation. I just want to do it 3 times so that you see it. The thing is very simple. In case you have but if both of them have equal interval, you have to something like extrapolate one to a negative sign so that it will not give you a very wrong answer. So let's look at this. If this one is reading a reading, this one will also give you the equivalent of the reading. Both of them will be the same. Now what temperature will this one be the same? So I just say x minus 32 over 2, 1, 2 minus 32 is equals to x minus 0 over 100 minus 0. So this one is going to give us x minus 32 over 180 is equals to x over what? 100. 20 here is 5, 20 here 9. So the next thing, we are going to something like cross multiply. Can just cross multiply, but x is also in this place. Because x is already in this place. So what do we do now? What do we do? So we're going to let me cross this to this side, and we have x minus 32 is equals to 5, that is 9x over 5. This one multiply this. So the next thing we're going to do will be minus 32 minus 32, or we're going to have x minus 9 over 5, that is 9x over 5 is equals to plus 32. But if minus causes something to plus, so we solved something like this before. I think we have solved something like that before. X minus 9 over 5x is equal to 32. So it stays this. So that the first one was minus 4x. This minus this will give us minus 4x. I think over 5 is equals to that one we did. That will give us minus 4x over 5. And the other one will give us 32. So this one multiply this divided by 4. So that have x will be equal to 32 times 5 over minus 4. That will give us 32 times 5. 2 here, 2 here 16, 2 here 1, 2 here 8. That is minus, that is 5 times 8, that is 40. Divided by minus 40 degree Fahrenheit or degree Celsius. That's what you are going to have. So another question can also come up. At what temperature will Fahrenheit reading be doubled of that of Celsius reading? At what temperature will Fahrenheit reading be doubled of that of Celsius reading? So let's look at that quickly and see what we are going to have. Let's look at that quickly and see what we are going to have. So we have Fahrenheit here. We have Fahrenheit in this place. Yes, we have Celsius this other side. 100 degrees Celsius, 0 degrees Celsius, 212 degree Fahrenheit, 32 degree Fahrenheit. If this one is reading, this one will be double of that x. So approach reading in Fahrenheit be 2 times that reading in Celsius. That's what we are looking at now. So what we are going to do the same interpolation. You can also use those formula to run it. It's just the same thing. This minus this, that is 2x minus 32 over 212 minus 32 is equal to x minus 0 all over 100 minus 0. So that's going to give us 2x minus 32 over 180 is equals to x over 1, that's 100. 20 here 9, 20 here 5. So we're going to have 2x minus 32 is equals to 9 over 5 x 9 over 5 x. So next thing we're going to do something like collecting items. We have 2x minus 9 over 5 is equals to 32. It's equals to 32. So the next thing, you take the LCM. This one is 1. I'll take this one 5 and 1. That is 5. 5 into 1. That's 1 into 5. That's 5. Already done division, subtraction and addition or fraction. Already done that. So 5 times 2x, that's 10x minus 9x, that will be equal to 32. So we're going to have x to be equal to 5. Yes, that is 5x over 5 is equal to 32. Then the next thing, our x will be equal to 5 times 32. 5 times 32. 5 times 32. So x will be equal to 5 times 2, that is 0. 5 times 3, that is 15 plus 1, 16. That's 160 degree Celsius. Or this thing is x, and x is the one that is in degree Celsius. Or 2x will be 2 times 160, that is 3. That's 2 times 0, 0. 2 times 2, that is 12. That is 2 times 1, that is 2 plus 1. 320 degree Fahrenheit. So that is the temperature is 160 degrees Celsius or 320 degree Fahrenheit. So that is temperature which the Fahrenheit reading will be doubled of that of Celsius reading. So that's how we resolve this. So we are going to look at general questions now that involve interconversion of temperature scale, maybe from link, maybe a scale, or something like mercury, the length of mercury thread measured in millimeter, converted to degrees Celsius, and other things like platinum resistance thermometer measured in ohms, that will move it to degrees Celsius and others. So that's what we are going to quickly look at now. So the first question we are going to look at now is as follows. We're going to look at 2 to 3 questions, then we are out of this class. So the first question is as follows. So you can jot it down if you wish. The question goes like this. If the resistance of a platinum wire in a platinum resistance thermometer, if the resistance of the platinum wire in a resistance thermometer is 5 ohms, is 5 ohms at steam point, is 5 ohms at steam point, and 2 ohms at ice point. Now, steam point is still the same thing as upper fist point. Ice point still means lower fist point. You take note of that. So the resistance, the platinum resistance thermometer, is reading 5 ohms at steam point, and is also reading 2 ohms at ice point. So, what temperature on the platinum resistance scale? What temperature on this platinum resistance scale will correspond to a resistance value of 3 ohms? Will correspond to a resistance value of 3 ohms. Now, let's assume we are comparing this to Celsius scale. Because Celsius scale is very common. It's very common. Let's assume we are comparing it to Celsius scale. Now, they said the ice point, which is the lower fist point. Now, what is the lower fist point of Celsius scale? 0 degrees Celsius. It's okay. For 2 ohms, it was at 0 degrees Celsius, which is the high point. Then for steam point, when you have steam point, upper degrees Celsius, that's 100 degrees Celsius. That's upper fist point. That's for 100 degrees Celsius was 5 ohms. It's okay. Which degree Celsius will correspond to this one? Let's call it X. So if 5 ohms correspond to 100 degrees Celsius, 2 ohms correspond to 0 degrees Celsius, 3 ohms correspond to what? That's what they are trying to ask in this place. That's what they are trying to ask in this place. So how are we going to do this? How are we going to do this? So, what we are going to do, although there's a formula they do use for this, it's a formula they do use for this, but I'm not going to use that formula now. I'm going to solve this out with my interpolation, from my interpolation. So, let's say we draw for this resistance scale. Upper side was 5 ohms, the lower side was 2 ohms. Let's say we draw for this section scale, 100 for the upper side, then 0 for the lower side. So we're going to have something like this. So if this one is reading 3, the reading is 3, what will be the equivalent reading? Yeah, that's what they're trying to ask. So that's x minus 0, x minus 0 over 100 minus 0, 100 x, the same thing, x minus 0 over 100 minus 0 over 100 minus 0 is equals to, now what corresponds to x in this place? 3. So I'm going to do 3 minus 0, 2, 3 minus 2 over 5 minus 2 over 5 minus 2. So that's all. This minus this over this minus this over this minus this minus this. Let's go interpolation. So the next, so we have x over 100 will be equal to we have 1 over 3. The next thing, s will be equal to this one times this s 100 over 3. That's what we have 100 over 3. And this is approximately 33.3 degrees Celsius. That will be approximately 33.3 degrees Celsius. So it's 3333 all true. So that's what we are going to have for this. That's what we are going to have for this. So we can establish formula for converting from resistance, platinum resistance scale to section scale. For example, like this. Let's say if this is the platinum resistance scale, this is section scale. So it's reading 100 degrees Celsius, 0 degrees Celsius. So let's look at the resistance at 100 degrees Celsius, the resistance at 0 degrees Celsius. Then if it is reading in degrees Celsius, let's look at the resistance at the unknown temperature. Because let's say this one is reading theta degrees Celsius. So what will be the resistance at the unknown temperature theta? Or we can also call it at the unknown temperature T. The unknown temperature T. But in most textbooks, maybe you see theta there. That's why I'm using theta at the temperature here. So the next thing, let's check. So we're going to have this minus this. That's arrow theta minus arrow 0, then over 100 minus this. Arrow 100 minus arrow 0 will be equal to, so let's figure this first here, theta minus 0 over 100 minus 0. So I hope you can remember, pick this first minus this, that's the reading minus the lower fixed point over the upper fixed point minus the lower fixed point. So we got to reading here minus the lower fixed point, then over the upper fixed point minus the lower fixed point. So in this case now, theta will be equal to arrow theta minus arrow 0 over arrow 100 minus arrow 0 times 100 degrees Celsius. That's 100 degrees Celsius. So this is how you move from platinum resistance thermometer to Celsius scale. So platinum resistance scale to Celsius scale. This is how you move from that. So you can also apply for this question. Okay, let's apply for this question. Let's see what we're going to have. Remember, arrow theta is the resistance at the low temperature. Arrow 100 is the resistance at 100 degrees Celsius. Arrow 0 is the resistance at 0 degrees Celsius. Let's try and see. Now, what is the resistance at the low temperature? Which is 3, that's 3. Minus resistance at 0 is 2. Resistance at 100 was 5. Resistance at 0, 2 times 100. That give us 1 over 3 times 100. That give us 32.3 degrees Celsius. That's what I'm going to have. So you can also use this formula established from this place. You can also use that formula. So now let me call another question. Let's say, okay. If the length of mercury in a mercury in glass thermometer, if the length of mercury in a mercury in glass thermometer is 10 millimeters at ice point, is 10 millimeters at ice point. That is, at ice point we are having 10 millimeters. And 50 millimeters at steam point. The length of mercury in glass metal is 10 millimeters at ice point and 50 millimeters at steam point. At steam point. At steam point. At steam point. Are we together? Yeah. A, question A. The first question we will look at, question A. Question A. Question A. What length of the mercury would correspond? What length of the mercury would correspond to a temperature of 30 degrees Celsius? What length of the mercury? What would the length be if the temperature is really 30 degrees Celsius? The temperature is really 30. So the thermometer we are using now is calculated in degrees Celsius. Please take note of that. Then question B. What temperature will correspond to a length of 80 millimeters? What temperature will correspond to a length of 80 millimeters? So remember, the upper frequency is already 50 millimeters. So even though we are not something like able to measure, maybe we now measure the length was 80 millimeters. We can now measure above this temperature. So you can also look at that. Then number C. What temperature will correspond to a length of 40 millimeters? What temperature will correspond to a length of 40 millimeters? You can also look at that. What temperature will correspond to a length of 40 millimeters? What temperature will correspond to a length of 40 millimeters? So the first A, question A, is to, therefore you draw. So let's say for this mercury, the upper side is 50 millimeters, the left side is 10 millimeters. So this one is the upper side is 100 for degrees Celsius, so that is 0 degrees Celsius. That's okay for the question A. This one is really 30 degrees Celsius. 30 degrees Celsius. What would this one read? Let's say read X in millimeters. So from interpolation now, I can just say X minus 10 over 50 minus 10 will be equal to 30 minus 0 over 100 minus 0. So X minus 10 will be equal to 40. So that is X minus 10 over 40 will be equal to 30 over 100. So let's say X minus 10 will be equal to 30 times 40 over 100. So this 0 cancel 0. So X minus 10 will be equal to 3 times 4 is 12. That's 12. So X will be equal to 12 plus 10. That is equal to 22 millimeters. So for 22 millimeters, we are going to have 30 degrees Celsius. So if this length is 22 millimeters, the stuff we'll be having will be 20 millimeters. That's what I'm going to have. So please take note of that. It's still interpolation. Just solve it out. So we will have 22 millimeters for 30 degrees Celsius. Now let's check what degree Celsius will correspond to 80. Assume you think I read 80 millimeters. What degree Celsius temperature will correspond to 80? Now let's check. The upper side is already 50 millimeters. Then the downside is 10 millimeters. So we can write it here and say if the reading is 80 millimeters. But I'm not going to do it like that. Then 0 degrees Celsius, section B. Then this one is 100 degrees Celsius. So this one will be X degrees Celsius. If you do it like this, you're going to have a very perfect answer, the correct answer. But I'm going to do it like this. Since 80 is higher than 50, I'm going to draw 80 upward. You have 80 millimeters here. So that I also draw the reading upward. So what reading will correspond? The reading will still be higher than 100. So that's already telling me if I have an answer lower than 100 means I'm not correct. So the reading should be higher than, since it's higher than the upper fist point, it will be higher than the upper fist point. Let's check. pick the unknown first, x, then minus the lower fixed point over 100 minus the lower fixed point is equals to the 80 minus 10 over 50 minus 10. So the unknown first minus this lower fixed point divided by this 100 and this lower fixed point is equal to 80 minus 10 over 50 minus 10. 80 minus 10 over 50 minus 10. So we have s over 100 will be equal to 80 minus 10 is 70 over 40. So we'll cancel this. So we have s to be equal to 7 times 100 over 4. 7 times 100 over 4. So can 4 into 100, I think that's 25. That's 25. 7 times 5. 7 times 5, I think this is 35 already. Yeah. So that's 5, that's 35. That's 5. Then 7 times 2, we're going to have 14. 14 plus 3, I'm going to have 17. So we're going to have 175 degree section. That's what we're going to have. 175 degree section. That's 7 times 25. We're going to have 175. 8 times 25. I think we're going to have 200. Yeah. Another. So you can see this one is 100. So that shows that we are correct. That shows that we are correct. We are very, very correct. Very correct. So the last question for the day, we are going to look at this. Now, the question is now, if the length is 40 millimeters, what will be the reading in degree Celsius? So question C, if the length is remember the upper fixed point is 50 millimeters, then the lower fixed point is 10 millimeters, then for this one 100 degrees Celsius, 0 degrees Celsius. If the reading is now 40 millimeters, what will be the equivalent reading in degrees Celsius that we are looking at now? So pick the unknown first, x minus 0 over the upper fixed point minus 0 will be equal to 40 minus 10 over 50 minus 10. So we're going to be having x over 100, that will be equal to 40. Okay, 40 minus 10 plus 30 over 40. This, we cancel this. We're going to have x to be equal to 30 times 100 over 4. This here, 25. So 3 times 25, I'm going to have 3 times 5, that's 15. 3 times 2, that's 6 plus 1 is 7, 75 degrees Celsius. So I'm having 75 degrees Celsius at 30 millimeters. So we have other questions, I think, coming from interpolation. You can also look at them. It's the same way, the same method, the same procedure we use while resolving all these issues. Please ensure you subscribe to this channel and review this video over and over again. So these are things and others what we're going to see in this temperature and heat measurement. So God bless you all. If you have some other review questions, we'll still update you guys about them. So thank you. God bless you.